Hi everyone, my name is Meredith Jordan and I'm your teaching assistant for the online lab for ESM 102. So this is just for the online section. You'll be sorry to know that the face-to-face students will not be getting these marvelous video updates week to week. But let's see, just to introduce myself, I am a second year graduate student at Portland State University. I'm getting my Master's of Science in Environmental Science and Management, and I'm focusing on mercury bioaccumulation in freshwater zooplankton. And that's a mouthful, and really what that means is that I'm looking at how different factors could change the concentrations of this toxic metal in fish. So I'm looking at climate change and nutrient addition in lakes, in particular in the Pacific Northwest. Let's see, I'm going to just show you and bore you a little bit, if I may, some of what I'm looking at. So um, part of why I'm studying this is that we get mercury in freshwater and in salt water, for that matter, from a variety of sources, but one of the most pervasive is coal burning. And the reason that I bring this up to you all is that we're going to be looking at energy sources a lot this term in 102, and coal burning is one of the primary sources of energy for the United States, and for that matter for a lot of developing countries as well. China, India, all of these places are pretty much just coming online with huge amounts of coal mining and production. And so one of the byproducts of coal burning is mercury, and that mercury gets deposited through wind and through rain. Any kind of wet deposition can move mercury that's in the atmosphere and move it all over the world. And so while things like volcanic eruptions and other activity, even just geologic sources of mercury, can contribute somewhat, really the biggest offender of adding mercury to a system is through coal burning. So what I'm looking at in particular, if you'll notice on the lower right, this little guy here is what's called a Daphnia, and that's a species of zooplankton that you'll find pretty much in any lake, pond, stream. And then there's also marine zooplankton. Unfortunately, I'm not looking at those right now, but hopefully someday I will. But what I'm really looking at is how different factors might affect how these little guys might take up more mercury and then ultimately give it to these larger predators like trout or salmon. This map here just gives you an indication of how much mercury we're actually looking at. This is a map from the National Atmospheric Deposition Program, the NADP. And if you'll notice, I know that this is an online class, so that there are many of you who are not in the Pacific Northwest area, but if you look at this area over by Oregon and Washington, you can see, based on the legend over at the right, that we're looking at concentrations of elemental mercury greater than 18 micrograms per square meter. So that's quite high. Hopefully we'll get to learn about each other as the term goes on, and you can introduce yourselves to me and tell me where you're living and what kind of sources you might be looking at, because I'd be curious to know. But you know, central eastern United States have quite high concentrations, as well as parts of Florida. And some of it has to do with, where the mercury is coming from. So if there's a coal burning power plant, say, in, a certain state, chances are you're going to have fairly high concentrations around there. But you also have wind patterns that move this mercury throughout the states. So it's a pretty significant factor. And the reason that I even care about this is that mercury is a neurotoxin, and it's particularly harmful to unborn children. So pregnant women are at particularly high risk. And if you look at lower income populations throughout the United States, oftentimes in certain areas, lower income populations rely on fish consumption as a main form of food. And so it's kind of turns into an environmental justice issue, and so that's what's of interest to me. This is just a quick little graphic showing you how mercury moves through a system. So let's say the clouds come, they've got some toxins from a coal burning power plant that's over here. It rains, deposits that elemental mercury into this lake. The bacteria that are in the sediment down here do this marvelous chemical process called methylation, which turns elemental mercury into methylmercury, which is a more toxic form of mercury. The phytoplankton, which is just another word for algae, take this up into their fibers and their cells. The zooplankton, which is that little Daphnia guy I showed you earlier, they eat that algae. Then other things like copepods and other organisms eat those Daphnia. Small fish eat those organisms, large fish eat those small fish, so on and so forth. Before you know it, you see this fisherman guy over here. You've got fish with pretty highly concentrated amounts of mercury, and the reason why is that it does not break down in the body. It doesn't go anywhere. It just kind of keeps building with each what we call trophic level. So by the time this fisherman is perhaps eating this fish, he could be ingesting toxic levels of mercury.